Tomorrow you have a quiz over Monday. No, Tuesday, but we cover Tuesday 1 page of notes and then some temperature and pressure conversions. What we're covering today, um, there'll be a quiz on that on Monday. We're learning 2 laws today. Anybody have any questions on these? We're good with them? So if you notice, the grades have not gone in. I didn't put grades in for the test, although they're all graded. They were horrible. People that made zeros, 16s, 9s. If you made a 0, a 16, a 9, you did none of your practice. And what really is very aggravating to me is I've been teaching stoichiometry. I have people that sat here and didn't even know how to get started. So obviously they've done no work at all on this. And I've been teaching stoichiometry since January. And I've had 2 people ever come in and ask me any questions during tutorials. 2 people. With that, I did have my 2 highest grades in here. Lena with a 90. That was before any Lowry loot. And Abby, you had 91 after some Lowry loot. So there is a 10-point curve on this. So what you see, there'll be 10 points added to it. Some of y'all, that doesn't really matter. And next time, if you're going to make a 0 on the test, don't put a Lowry loot on it. That's ridiculous. 5 points on the 0 means nothing. Don't put them up because don't keep them. So whatever your grade said, plus 10 would be your grade that would be recorded. So with that being said, there will be a retest in class on Thursday. If you passed, no, not on Thursday, I'm sorry, on Wednesday. If you passed, then you do not have to take it. If you passed and your grade wasn't like you usually like it to be, because I have people in this class that carry 100 averages all the time or really high 90 averages all the time. And this test, they didn't get that on. So if you passed, but it still wasn't a grade you're happy with, you can take the test on Wednesday and I'll average the 2 together. So that's a way of bringing your grade up some. If you didn't pass, then you will be taking the retest and it'll give you a chance to bring your grade up to 70, but you have to make a 70 on the retest to bring it up to 70. Your grade will not be lowered. So if you do worse on the retest, then I don't even have anything to say about that, but I'm not going to give you the lower grade. And the same thing for my people that did pass. If for some reason you blow the test on Wednesday, which you're not, and it lowered your grade when I averaged, I'm not going to do that either. So for my people that passed, y'all have until next Wednesday to think about whether you want to take it or not, or if you're just happy with your grade. So like Lena, yours would actually be 100 in the grade book. So, okay. All right. Any questions on that? I will have tutorials Monday morning, Monday afternoon, Tuesday morning, Tuesday afternoon. I don't know why I say that because I have tutorials all the time anyway. But those are your opportunities to come in and try to get it straightened out beforehand. All right. With that being said, if you'll pass your test up, we'll move on to gas laws. Hopefully everybody will fight easier. Yeah. Are you definitely?
Oh my God, I'm gonna cry.
Oh, Ed and I asked, you want us to work on the board?
We have a quiz tomorrow over what we just did on Wednesday. Okay.
Oh, I may have fallen down.
I really tried to. You can do it, it's all about it. I did too.
You can move that if you need. All right, does everybody agree on all those?
Oh. Not the last
Not the last one. What's wrong with the last one?
That's too many sick days.
Too many sick days. 30, you can only have one. So instead of
200. 200.
all right, here you go, ma'am. One sick fig makes it hard. And that test that y'all took, that's the same test I've used for honors chemistry ever since I've taught it, which has been now going on 6 or 7 years. I can't remember, except that I took one problem out to make it shorter, and I added some balanced equations, and some molar masses to make it shorter. So. The only thing that saved my day yesterday is that my kids got me a maid, and she came and cleaned my house. So when I got home, my house was perfectly clean. So that was nice. All right, so let's look at our laws. We'll see if my whatchamacallit wants to work. I've been struggling with it. So the gas laws is just using those things: volume, pressure, and temperature, and moles in different formulas. And really, basically, you're filling in all the variables except for one, and then you're doing a little algebra step and solving for your x, your unknown. And it gets a little bit repetitive. So the first one we're going to look at is Boyle's law. And it says that constant temperature, when we say something's constant, that means it's just kept the same. So on the equation, it would cancel out on each side. So that means we're not looking at temperature. We are looking at pressure and volume, and they are indirectly related or inversely related, however you like to say that. So what that means, if my pressure increases, my volume is going to decrease. It's the only inverse relationship. And that makes sense because the particles are very far apart. In a gas, it's the only compressible state of matter. So if I increase that pressure, it causes the particles to become closer, and then the volume would decrease. And our formula is P1 V1 is equal to P2 V2. So pressure 1, volume 1 is equal to pressure 2, volume 2. You'll be given 3 of those and you're going to solve for the other one. Your units must be the same. So in other words, if you have volume and one of them is given to you in milliliters and the other one's given to you in liters, you have to do some conversion to get them into the same units. All right, so we'll just look at a couple of problems here. Like I said, that's really simple, kind of gets real repetitive. A balloon is filled with 25 liters of air at 1 atmosphere pressure. So liters is the volume, so that's my V1. Atmospheres of pressure, that's my P1. If the pressure changes to 1.5 atmospheres, what is the new volume? So I changed my pressure, so that's my P2. And then my new volume is what I'm looking for, V2. All right, so I'm going to show you a couple of different ways. You can tell me, like, I'm going to show you, first of all, this is my formula. P1 V1 is equal to P2 V2. So I'm trying to find V2. That's what I need to isolate. So that means that it needs to be by itself. So I need to get rid of my P2. That cancels. And my formula for V2 becomes P1 V1 divided by P2. Remember, when you're rearranging a formula, if it's at the top on the side it starts with, so my P2 was at the top, then whenever I move it across my equals, it has to become on the bottom. So now you would just plug in all of your numbers. So my pressure 1 was 1 atm. My volume 1 was 25 liters. And my P2 was 1.5 atms. ATMs cancel out, and everything on there is 2 sig figs. So you multiply your top, divide it by 1.5, and hopefully you got 17 liters when you have a chance to check yourself. Is that what we got? Now, I said there's 2 ways, because this way is if you rearrange the formula, but of course you don't have to do that first. You could just plug in your numbers. And that's just up to how you like to do your math. Because I could have left my formula like this, and I could have said P1 is 1 atm, V1 is 25 liters, and then P2 is 1.5 atm, and then V2 would be my X. So that's if you want to plug in your numbers and then solve for it. So now I just divide each side by 1.5. And you would get your same thing. So do y'all like to rearrange the formula? How do y'all used to doing it? Rearrange the formula and then put your numbers in, or do y'all like to put your numbers in and then just solve? Rearrange the formula? Okay, then I'll kind of work them that way. But if you want to do it the other way, that's also fine. I mean, either way, you just a little bit of algebra. All right, why don't y'all try the next one? Same formula still. A balloon. Talk about a balloon filled with some pressure. If you anybody need a calculator, or maybe some floating around. So what did we get for that one? 2.2, and what are my units? ATM, very good. So this would have been my formula if I rearranged it first. And then I could have just plugged in my numbers. So 1.3 for my pressure, volume, 73 liters, and then my 43 liters. Liters cancel out. I'm left with just atmospheres. And then I would have got my 2.2 with 2 sig figs. All right. The other one that we're looking at today is Charles's law. And it says a volume of gas is directly proportional to the Kelvin temperature if the pressure is held constant. Once again, that means if I'm talking says the pressure is held constant, it's not part of this equation. So as the temperature increases, the volume would also increase. If the temperature increases, I'm putting more kinetic energy into the gas, so the particles are start going to move around and spread out more. Your temperature must be in Kelvin. So if it's in Celsius, you got to add 273 to it. And your sig figs come after you've changed it from Kelvin, not from the problem, because sometimes Celsius is going to have less. So after you've changed it. And even if your question asks, what is the final temperature in Celsius? You still have to change to Kelvin to put it in the formula, get your answer in Kelvin and subtract 273. The formulas are designed around the Kelvin scale because it doesn't have any negative numbers. So you got to work in Kelvin. And my formula is V1T2 is equal to V2T1. Temperature is always on the opposite side. So like what I mean by that, this is V1. If I'm at a V1, T2 goes with it. If that would have been P1, T2 still would have gone with it. T2 is kind of always on the opposite side of what you think it has to be. And the temp has to be in Kelvin. So we'll look at one of those and then y'all can work on one. It says, what is the temperature of a gas that is expanded from 2.5 liters? So there's my V1. At 25 degrees Celsius, anytime I see Celsius, I go ahead and change it to Kelvin. So I won't forget. So plus 273, 298 K, no place behind the decimal, to 4.1 liter at constant pressure. So that's my V2. Constant pressure doesn't mean anything, so I'm trying to find my T2. So my formula is V1T2 is equal to V2T1. Since I'm trying to find T2, I have to get rid of my V1. It's on the top on this side, so when it moves across, it's going to become on the bottom. I should say T1. So it becomes T2 is equal to V2T1 over V1. And now you just, once you've done that, you've done all the work, you just got to plug in your numbers. So T2 is equal to V2, which was my 4.1 liters, times my T1, which was my 298K, divided by my first volume, which was my 2.5 liters. So this volume is in two, actually both volumes I think are in 2 sig figs. So my answer can only have 2 sig figs. So what do we get for that? What, I'm sorry? Not 400, what we got, it went at 489 on your calculator? So it would become what? 490. 489 would become 490. Yeah. And does that make sense? If my temperature increased, should I see a change? Should my volume have increased also? Yes. So you got to do that quick check. All right. Why don't y'all try the next one? And then we'll. Did you hear if Zach was coming home? He's not okay. I have a couple of guys coming to talk back from A&M. I was trying to get somebody from the University of Texas. But Dandy, I don't know if you even know Dandy. He's not coming home. And then Zach was the other one I thought of. Oh, I did not know that. Mrs. Baker texted Dandy yesterday, but I didn't know that. It's a couple of good guys together. Anybody got an answer yet? 11 liters. Perfect. You always go by the one that has the least. And in this case, I think it would be, well, actually 8.3 is only 2 and 290 is also only 2. So that's what it's, so this is if you rearranged your formula and then you would have just filled them in. And then you would have filled in your numbers. So we would have had 8.3 liters, 369K. And sometimes I see that mistake because people want it, if it's V1, people want to put T1 with it. But remember, it's always going to be the opposite. And then come back and have my 290K. And I think on your calculator, you got like 10.56, but 11 to get your 2 sig figs. All right, on the next, I'm not going to work all these problems on the next page, but they're good practice. I'm going to give you the answers. So those are the answers, except there's one mistake on it, but I don't think it's till later on. So if you want to jot down your answers, it's good practice along with your other one. There's not a top one. That is the first one on the page. This is the one I need to change. That 239 should be 237. It should be from, let's see, you should have gotten 510K. And then when you change it to Celsius, that's a 237, very messy. And then same thing here because of sig figs. Negative 89 degrees Celsius. And both of those are sig figs. And it is kind of a pain when it's in Kelvin to take it back to Celsius. Let me say something real quick before we go. Notice that it says, what is your temperature in Celsius? That's one of the ones I was talking about. You have to still work through it in Kelvin and then come back and get your Celsius. Also, this says, what temperature in Celsius would 50 mils of a gas be at if it occupies 740 mils at standard temperature? So it seems like you don't have enough information, but remember we talked about yesterday, standard temperature tells you information. Does anybody remember what standard temperature is? It's on your pink sheet. Standard pressure is 1 ATM, but in this one we need standard temperature. So what would it be? But we don't want it at 0 degrees Celsius, so it would be what? 273. So remember that gives you some information. If it says standard temperature and pressure, that actually is giving you some information that you need. And then if you pull out your pink sheet and go to the other side where it says behavior of gases, you may want to mark these because this is your sheet to use on quizzes, tests, all that good stuff. So Boyle's law is this one. It's written. But the next one down is Charles's. And that is how the equation was originally solved, but when it's in fractions, it's confusing. So if you take it out of fractions, then you have V1T2 is equal to V2T1. And then it's, I don't know, just when things are in fractions, they seem a little harder. All right. So that gives y'all a little bit of time to do some practice. And if you have any questions, please let me know because we're right at the beginning. It's a good time if you're stuck on any of them. And we'll move on to a couple more laws tomorrow.